Hi everyone, we're going to use the principle of mathematical induction to show that this statement is true for all natural numbers n. This is a more advanced problem, so it's not too bad, but I assume that you've already done some easier ones, so you know what condition 1 and condition 2 is. So in condition 1, we're going to check for n equals 1, and we're going to plug that in here, and it should equal 1 cubed, which is 1. So we have 1/4 times 1 squared, and 1 plus 1 is 2, so that's going to be 2 squared. So you get 1/4 times 4, which equals 1, which equals the 1 cubed, because 1 cubed equals 1. So basically, it satisfies condition 1, and we're moving to condition 2, assuming that it works for some k. So, and then check to see if it works for the next term, k plus 1. So I'm going to copy down the first equation again, plus dot, dot, dot. But instead of n, I'm going to put k. Okay. And now we're going to check for the next term, which is k plus 1. So I'm going to copy him down. 1 cubed plus 2 cubed plus 3 cubed plus dot, dot, dot. It should be a plus k cubed. And the next term is going to be k plus 1 cubed. Because I just substituted k plus 1 in the previous term. Alright, and then for here, on the sum part, I'm going to put k plus 1 squared times, I'm just going to, the next term after k plus 1 is k plus 2. And then put the square. So we want the left side to equal the right side. And I already know what this equals. This equals 1/4 k squared times k plus 1 squared. And then I'm going to add my new next term here, k plus 1 cubed, and that should equal this. So we're going to have to simplify it and make the left side look like the right side. So the first thing I'm going to do is go ahead and factor out a k, because this is like one set, two separate things. I'm going to factor out the k plus 1 squared, because that's what we have here. So factor out the k plus 1 squared. When I do that, I get 1/4 k squared plus k plus 1 period. So then what I'm going to do is I want the 1/4 to go in front of everything. So I'm going to go ahead and multiply. I want these two, I'm going to pull out a 1/4 here. And when I do that, I can do that if I put 4 in front of this term here. Okay. Now, when I do that, now I can pull the 1/4 out and put it in front. We keep wanting to make the left side look like the right. And then what I'm going to do is I pulled this out and pulled him out front. And now I'm just going to deal with this. So this is k squared plus 4k plus 4. And so that's 4k. So I'm going to factor that. I'm going to copy this part down. And this is going to be, if I factor this is k plus 2 times k plus 2. And then finally, I'm going to write this as 1/4 k plus 1. There's 2 of those. So that's going to be k plus 2 squared. Thus, we have proven what had to be proven, and condition 1 and condition 2 have been satisfied. So the given statement is true for all natural numbers n. All right, thank you and have a nice day. Bye-bye.